Thank you
Mhm.
for doing this interview with me today. To begin, my name is Annie, and I create Sustainability Beyond the Lab to showcase sustainable innovations and make them more accessible for a general audience, as well as um, show the barriers that prevent their scale up. So, to start, could you also give an introduction of yourself and then tell us about your research, especially at the Cornell Atkinson Center for
Atkinson
Sustainability?
Center. Yeah. Okay. So thank you for inviting me to this interview. So my name is Jintong Gao, and this is my second year as a postdoc in mechanical engineering at Cornell University. And I'm also a postdoc fellow at Cornell Atkinson Center for Sustainability. And the Atkinson Center brings together researchers from different fields to address the sustainable challenges. And I think its mission is very closely connected to your website because we are all focused on sustainable problems. And for my research, when I was a PhD student in China, I was working on sorption systems, including the sorption heat pumps and thermal energy storage. So in sorption, we will use a material called solvent to capture water vapor. As the vapor is captured, it will condense into liquid and release heat. So we can provide heating using this material. And the interesting is that when the vapor is captured in another place, water will evaporate to keep the balance of pressure. So
Mhm.
we can provide heating and cooling in one system. So that is how the sorption works. We
Mhm.
just deliver thermal energy from one place to another place,
Yeah.
and we can control this process whenever it is needed. And then I extend my research to solar desalination. And I think the underlying processes are closely related because in desalination means we separate the clean water from the salt water. The idea is very straightforward. We
Mhm.
just heat the salt water to produce water vapor, and this vapor can condense into liquid, and then we can get clean water, which is also called the distilled water.
Yeah.
So I think they are very similar processes, and these are the major parts of my research. Yeah.
Yeah. Thank you for giving that overview on your research and especially the projects that you're most known for as well. For audiences that aren't familiar with like your research on producing both green hydrogen and clean water from seawater using
Reward. Yeah.
sunlight, um, how does this process work and what problem is it aiming to solve?
Yeah, actually, so that project is our project sponsored by Atkinson
Mhm.
Center. So our aim is to produce clean water and green hydrogen, and the sole input is the natural sunlight and seawater. So we will combine the solar desalination with water electrolysis. And first, we will capture the sunlight using a photovoltaic panel to
Mhm.
generate electricity. And this electricity will be used for water electrolysis to
Oh.
split water into hydrogen and oxygen.
Mhm.
And it's very interesting that the solar PV panel besides of generate electricity, it will also generate heat,
Mhm.
and this heat will influence its performance. So PV panel needs cooling, and in our solution, we will use this heat to for desalination. We
Mhm.
will use this thermal energy to heat seawater and produce vapor and clean water. And this clean water will be further used for electrolysis. So we just combine the PV panel cooling, the PV panel electricity generation, and also the thermal desalination. And we combine them into one system to produce green hydrogen and clean water. Yeah.
Mhm. I'm curious, what kind of inspired this project of combining like solar desalination as
Mhm.
well as hydrogen production? And what advantages does this like integrated approach offer over like conventionally just treating them separately?
Oh, there are several different effects of enhancement. First, as I mentioned before, the PV panel, it needs cooling.
Yeah.
So we will use the, the solar desalination to cool the PV panel to control the temperature, and which can increase its efficiency of electricity generation. And at the same time, the water electrolysis, our electrolyzer, it lacks heat.
Hmm.
It can work more efficiently under a high temperature. And we will feed the vapor directly into the electrolyzer. And this vapor can condense into the electrolyzer and release heat. So it can increase the temperature of water electrolysis and also increase its efficiency. So
Yeah.
I think there are two combined effects for enhancement.
Hmm.
Yeah.
Yeah, that's really interesting how
Mhm.
like the system kind of benefits off each other.
Yeah.
Yeah. What do you see as kind of the biggest barriers preventing
Mhm.
like solar powered hydrogen and water production technologies like the one you were working on from being deployed on large scale or sustainable innovations in general?
I think there are a combination of different factors
Hmm.
that prevent its adoption, wide adoption. So for example, so we are focused on both fundamental questions and practical device,
Yeah.
and I think there are one of the major challenges is that the solar energy is very weak and dilute. For example, if we consider the clean water production for the traditional system with 1 square meter area, we can only produce 2 kilograms of water in one day, and
Mhm.
which is even not enough for humans' daily drinking.
Oh.
And for water electrolysis, it is not only energy intensive, but it will also consume water. To
Mhm.
produce 1 kilogram hydrogen, we will need at least 9 kilograms of clean water.
Mm.
So that is why it is will consume a lot of water, and the solar energy is too weak and too dilute to
Mm.
produce that much of energy. Yeah, and so we are using one solution, which is called the condensation heat recovery. So the concept is very straightforward. In desalination, we have water evaporation, which will absorb heat, and we also have vapor condensation, which can release heat. And this release heat is also useful. We can recover and reuse this energy to drive a new cycle. So that's why we can reuse the same input of energy for several times in a multi-stage configuration and multiply the water production in a specific area rather than using an extremely large device.
Yeah.
I think it's a very promising
Mhm.
solution.
Yeah. That's interesting to hear kind of the trade-offs as well as
Mhm.
like research being done to provide solutions for them.
Mm.
Looking ahead maybe 10 to 20 years in the future, what emerging technologies in like solar energy or water desalination
Mhm.
are you most excited about?
And most exciting, there are many promising and exciting technologies,
Hmm.
and actually there are many exciting papers published every year in this field. So I think uh, in my mind, I think the most important thing is we need focus on the real applications of this system. And um, maybe let's take an example of clean water production. We are There are many people are living with the crisis of water shortage, and
Hmm.
but and there are many regions and countries. But in their regions, they have already developed some infrastructures, some existing factories or desalination plants, And when the company make a investment plan, they will consider these existing systems
Yeah.
because they want to minimize the cost.
Hmm.
So it indicates if we have a good technology alone, it cannot guarantee a widespread adoption because they already have some mature technologies. Yeah, and I think one promising solution is to found and break the limit of existing technologies. I mean, for example, for the traditional desalination plants,
Hmm.
when they purify the salt water, it will generate the high salinity brine, and which cannot be treated with the traditional system. And this brine will be discharged to the environment directly. And we are thinking for a method to treat with this high salinity brine because the traditional cannot treat with it. And so we are not competing with them. We just provide more applications for our technology. And even we can achieve the zero liquid discharge, it means we will separate the salt, totally separate the salt from the salt water. And there are some precious metals sources in the salt, and which like the nickel or lithium. Yeah,
Yeah.
so
Um,
that's why. Mm,
yeah, that's
okay.
really interesting to hear. I was also very interested how you said like there's a lot of infrastructure put in place for like traditional methods, which
Mhm.
makes it difficult to want to actually like fund these new projects as well.
Yeah.
Before we wrap up, is there anything that we haven't discussed during the interview that you think is important for people to know about like green hydrogen, water purification, or sustainability?
Yeah, actually, uh, so what we are uh, so for the research side, what we
Mhm.
are very interested in is that I think it's very meaningful and important to find some practical and meaningful targets to achieve some targets uh, as milestones for our technology. For
Mhm.
example, um, I think if we can achieve a really high water production in a small device, for example, we can use a 1 square meter device to achieve 20 or even 30 kilogram of water production.
Mhm.
And this can make it much easier to push it into the market as a distributed water production technology. Yeah. And so for the researcher, I think I mean, I'm also think about we also need to keep learning and also how to learn how to be a good learner. I think this point is also mentioned by another interview in the previous interviewing, and
Yeah.
I fully agree with him. And because in our research we are to find a innovative method or solution, we need to address the challenge that is related to multi-scale and different type of physics. So we need to really understand the basic physics to address these problems, and we can develop our insights into this and how good collaborations with other researchers. I think this is very important for a researcher. Yeah.
Thank you so much for sharing both your research as well as your perspective on like scaling technologies and the future of like research as well.
Thank you.